on a semi-generalized pre-closed sets. First, the whole video is based mostly on the paper written by Bhat and Navalagi in 2016. So all the notions are taken from their paper, almost all the notions. They were introduced by them. I mean the notion of sgp-closed and open set in particular. Other papers on the topic will be mentioned later. First, recall the idea of a topological space. I think that you are familiar with this concept. We have a family of subsets that is closed under finite intersections together with arbitrary unions, and both the whole universe and the empty set are considered as open, and the complements of open sets are closed. The union of all open sets contained in A is the interior, and the intersection of all closed sets in which A is contained is closure. Moreover, from other papers we can recall these definitions. Among many other classes of sets, we have semi-open sets, as you can see here, if A is contained in the closure of interior, semi-closed, if interior of closure is contained in A, pre-open, alpha open, omega closed sets, which are somewhat more complicated because the requirement is that the closure of A is contained in U whenever A is contained in U and U is semi-open. Interiors and closures with respect to these classes of sets are defined in a standard manner, and pre-closure is defined in the following way, as PCLA. And now, our authors, Bhat and Navalagi, they introduce semi-generalized pre-closed sets. A is sgp-closed if the pre-closure of A is contained in U whenever A is contained in U and U is semi-open in X. So there are three aspects, yes? The aspect of generalized closed set, of semi-open, semi-closed set, and pre-closed set. Moreover, if we replace pre-closure with standard closure and semi-openness here with openness, then we speak about generalized closed sets, which are, older concept. The complement of any sgp-closed set is sgp-open. The authors prove that the class of sgp-closed sets is contained in the class of closed sets, so every closed set is sgp-closed. Because assume that A is closed, then from our previous knowledge we can prove that pre-closure of A is contained in the closure of A, but the closure of A is identical with A because A is closed. So now suppose that A is contained in G where G is semi-open, but in this case we have the following line of inclusions, that pre-closure is contained in A, it's contained in G. So A, by the very definition of sgp closed set, can be considered as sgp-closed. The authors say that the converse of the statement above is not true in general. There is their counterexample, very simple universe ABC, and this is our topology, and they say that AB is not closed, but it is sgp-closed. Well, to check this, we didn't check this fact. To check this, you should perhaps you should calculate all the closures, pre-closures. So you should make some calculations and just check it if they are correct or not. The authors give us several other inclusions and relationships. For example, we may say that A is GP-closed if pre-closure of A is contained in G whenever A is contained in G and G is open. So then we have not sgp-closed, not generalized closed, but GP-closed, generalized pre-closed. And they prove that sgp-closed sets are GP-closed too. So every sgp-closed set is GP-closed, but the converse is not true, and again we have a kind of counterexample here. Moreover, the fact that we can prove the fact that every omega closed set is sgp omega closed. Okay, the proof goes as follows: yes, that if A is omega closed and G is semi-open, such that A is contained in G, but then by the definition of being omega closed, the closure of A is contained in G. But we have that preclosure is contained in closure, so preclosure is contained in G, and due to the definition of sgp-closed sets, A is sgp-closed. The converse, as we can believe, is not true. There is a kind of counterexample in the paper. Many other relationships of this kind are proved in the paper. So finally, the authors propose the following diagram. If you are familiar with these classes of sets, then you can analyze this diagram. And as for the other notions and other facts, for example, there are some results about subspaces too. We may assume that A is contained in Y and Y is contained in X, so Y is a topological subspace of X with some topology. And now, if A is sgp-closed in X, then one can prove that A is sgp-closed with respect to Y too. As for the closure and interior, of course, they are defined in a standard manner with respect to sgp-closed sets. And for example, the authors prove the following theorem, that if X, some point X, is in sgp closure of A, then it's equivalent with saying that the intersection of A and V is non-empty for every sgp open set V such that X belongs to V. This is typical, yes, but it's good to know that this property holds for sgp closed sets too, for sgp closure. What seems to be more important is the fact that for every A contained in X, for every subset A, we have that A is contained in sgp closure and sgp closure is contained in closure. The authors say that both inclusions can be proper, but in fact they prove only one thing, one fact. You can analyze this example that is here. Namely, they prove, if they are correct, that as you can see, some set E is identical with its sgp closure, so it is sgp closed, and it's contained in its standard closure, but it's different than its closure, it's not closed. Okay, I said that this means that E is sgp closed, but in fact this should be proved, okay, and they prove it, that every set is sgp closed exactly when it's identical with its sgp closure. Okay, among other properties we have, for example, this, as that sgp closure of the union is the union of sgp closures. Other parts of the study in question of this paper refer to the problem of limit and to the notion of neighborhood. Moreover, these authors and other authors wrote some other papers about sgp closed and sgp open sets. They analyzed the notions of continuity or homeomorphism, separation axioms, resolvability, and other topics. Moreover, there are some papers about sgp closed and sgp open sets and functions in some non-classical frameworks like intuitionistic and intuitionistic fuzzy sets too. And as for the bibliography, it is here. The initial paper of, about the sets is this one, as you can see, and there are some other papers too. Thank you for your attention.